manifestation of the water table. Here, the stream. So the water level up there was a bit higher than the stream level because the hydraulic head there is higher than the stream level. We have this is a gaining stream, so the groundwater is flowing from higher head up there to lower head. And what we're looking at here then is saprolite that would form the nidozone overlying the water table. This is weathered out. Well, this is saprolite, and remember that saprolite is weathered rock that retains the fabric of the parent rock. So that's one of the defining characteristics of saprolite, that it has the fabric of the parent rock. And you can see the layers here. That is inherited from the parent rock. If you remember from the lecture, the bedrock around here is biotite gneiss. So this fabric here is inherited from that. So what I want you to do for the exercise here is really to go through what you would do if you encountered an outcrop like this and wanted to document what it is. And there's two. Well, there are a couple of different perspectives you could take on it. The most important one, in my view, is that you develop an accurate description of what is here. And it's accurate and, I would say, it's objective. And so what that means is you're going to describe the appearance, the structure, the texture, color of what you see. You can do that with maps. You can do it graphically with sketches, and you can also do it with text. And then once you've done that, and you'll have a couple of ways of doing that. Then once you've done that, you can also describe it in terms of genetic, how it got this way, and kind of your interpretation of what it is that you're looking at. But one of the things that we need to be clear about is that your descriptions of what here, your objective descriptions of what you're looking at, that's going to be pretty close to the truth. You see it, which is what's there. Your ideas about how it got this way, maybe that's true, but but ideas about how things form change, and almost certainly the ideas about how you think it got this way will change. So you want to make sure that you're not mixing up, or you want to make sure that you're separating out descriptions of what's here, what this looks like, from how it got this way. All right, so for descriptions of what's here, our eyes are drawn to these nice veins, and you can see a lot of detail right here. But what I would recommend doing is trying to get the big picture of what's here, and I'll take this overall region and come up with the big picture of the major features that we're looking at, and do that first, and then start focusing in on more of the details. If you get drawn into the details at first, then you can maybe overlook some big aspects that could be important. So if we do that, and we take a step back, well, first of all, I guess, before we even get started with any of this, there's another safety briefing that we need to have down here. So the big issue with safety is stuff overhanging. And we can see this tree here. When you're working down here, this tree is up there. You see that it has come down with some extreme prejudice. So, that's the problem we have with tree up here, too, that we need to be cognizant of. And so it's looking pretty precarious. And as a result of that, I want to avoid that area. We have it scraped off, and really try to minimize being over there right underneath that overhang. If you do go over there, you have hard hat. If you do go really past, like right here, I'd like you to wear a hard hat just to protect from overhanging stuff coming down. From a safety issue too, the stream is pretty mellow right now, and there are a bunch of us, so probably minimal concern about this. If we were here by ourselves, we probably want to be letting somebody know that we're down here in case something does happen. The stream does rise in heavy rain, and so that's just something to be aware of. Okay, so we want to go and start off with a description, and well, I guess what we're going to do is two types of descriptions. One would be a reconnaissance type description that involves a sketch and descriptions in the book, and then we'll do a more detailed description that will use a photographic base map, and that photograph will allow us to take a look at features here on the outcrop and then locate those features on the photograph, and then describe the features on the photograph using information that we get in the field. And I'm saying this carefully because what I want, when you get to the photograph, what I want you to do is use it as a way of describing what you see in the field, not the other way around. Okay, it's tempting to just draw stuff on the photograph, but this is actually quite complicated in here, and the photograph will be most valuable in taking what you see in the field and then using it to spatial distribution. Okay, so we want to get some sketches, and before I get started with any kind of sketch, I like to take a step back and just get an overview of what the important features are here. So, what do you think?
How big is our area?
Well, I would go from over there, sort of get covered around that corner, and then over to here. We haven't really scraped behind here. In the front of it, there's some web pages that show how cross-section was done of this area back a few years ago. And at that time, we were able to see this whole area. This tree was still up there. I go through the steps of how I use a photograph for mapping and then turn that into a cross-section. And that shows this whole outcrop. It's just kind of, it's harder to get over there, so I think we'll just go to about here. So within that extent, what do we see is like, if we were to divide this up into units where each unit has similar characteristics within the unit, but characteristics that are different from the other units. And by characteristics, I mean color, texture, structure, those types of things. What would you say would be the units to it?
Soil.
So a separate layer all the way up top would be like this stuff. This part goes behind you. And particularly dense roots have horizontal roots, let's say, and then vertical roots, and then what? There's a layer.
We'll call it soil loam.
That stuff up there?
Yeah.
And then, and then what do we got? This stuff here?
Yeah.
So what does that look like?
The V horizon?
Yeah, well, that's kind of the V horizon. That would be, I guess, an example of a genetic implication or genetic interpretation. Well, just in terms of the material description.
Like loam or regular?
Yeah, well, I mean, we could get a grain size distribution maybe. If it's loam, that's going to imply something about the grain size. Right.
Okay. Now I'm trying to remember the grain size. It's that sand.
High sand. No?
No. Okay.
Okay, so it's clay.
It's mixture of, yeah, well, there's definitely clay size, so it's like silty,
That's silty clay.
silty clay. Yeah.
So silty clay. What about a fabric?
You have to look at the whole thing
You
to
see,
see fabric.
you see, this is where you would look for the fabric, and I'll scrape it. See,
Very like style or
it's
crumbly.
yeah, but there's not really much in the way of a fabric here. So this looks pretty uniform. So we could just call it massive. So this may be a massive from a soil perspective. It has like a weakly developed blocky texture, but from across the way, it looks structureless, really. Okay, and then so that would be a layer, and then the boundary. See the boundary? See that?
Yeah.
So right here, you can see that go across. So it's not scraped over there, but you can see right here, it's right there. That's a sharp contact. And you've got down here, these layers going like that. So the erosional contact. And what kind of a surface is that? The geologic name? Yeah. So, big difference in age between these rocks and this material. This is probably recent soil, and these are weathered out. The gneisses are Paleozoic. So this is weathered from Paleozoic parent rock. So there are 2 units. This is the 3rd unit. And what do we want to do with this? So here's some layering. You can see the layering better down there. We want to just have 3 units. Basically 1, 2, and 3. Yeah? So just from over there, this right here you would put as the same unit as that.
The second unit?
So right here, you would group that as the same unit as that.
So if you're splitting it into 3, you're saying, because we've got the very top, and then we've got this kind of massive, and then if you're saying there's 3 units, that you're saying from everything from that erosional surface down is the same thing. Does everyone agree with that? Does it look identical from the top of that erosional surface to the bottom? What's different? Yeah, so if the color's different, what does that tell us about? What does it mean? Something different is going on. So then should we define it as a different zone?
This is kind of going more into the interpretation, but we discussed that this is like a satellite, right? And so the genesis of all this from the knife, in terms of like metamorphosis, it would be the same as that, right? So I guess that's what I'm kind of like, I don't know if I should count this all as one, or separate it by the minerals, because the genesis is metamorphosis, right? So.
Mm-hmm. But lots of stuff happens after Genesis.
Looks like we got lots of oxides at the top and nothing in the bottom. I would want to kind of find somewhere in the middle of the representation.
In addition to the iron oxide color, what else do you see in terms of like the fabric there versus here?
Yeah, if you on a magic banding.
Yeah, so you see the banding there. What about here?
I see banding if you left aside.
Yeah. But it's definitely different,
Yeah.
right? So here it's really well defined. I mean, that looks like nice. But here you can kind of tell that it's banded, but the bands are much less distinct, and we're losing the definition that we have down here. So it seems like up here we've got pretty strong orange and brown colors and layering, but somewhat indistinct layering. And then down here it's grays and tan colors. We don't really have these orange brown. We've got much better defined layers to the rock fabric. Yeah. So these colors here are what you get from iron oxide. There are 3 main iron oxide minerals: limonite, goethite, and hematite. Limonite is kind of yellowish, goethite is brown, and hematite is red. And you can get combinations of them that give you these different shades. They have somewhat different oxide or oxidation states. And so, I mean, these are indicative of oxidized iron. The gray colors down there are, well, we can go and check out what they are. In the parent rock, we have diatite and hornblende, and those are the iron-bearing minerals. So when they oxidize, you can get these colors. So we can divide this saprolite unit. I would say this is the top of the saprolite, and we lose the rock extra here. And within the saprolite we have really two zones, this iron oxide stained zone where the layering is less distinct, and then this underlying zone. Yeah, it looks like we've got a weathering front that is oxidizing the iron minerals that's moving down, and it's also doing something to the fabric to make it less distinct. Okay, so we got 4 units. We've got a sharp contact between these two, and I don't know, probably sharpish contact. It's hard to tell just we don't really have a good profile here for that upper horizon. But then this contact is going to be more gradational and more kind of undulating. It looks like maybe like right in here, then it kind of comes up a bit. I think you can locate the boundary between the iron oxide stained areas and not fairly well, but it's definitely a lot more gradational than this. Okay, so those are some 4 main regions, zones, or units. And so, from a sketch point of view, I would go for that first. Those are going to be, people have different levels of artistic ability, but just getting the 4 main zones, you should be able to all do that. And then we can start to get in some more detail. And then from a detail point of view, what kind of things do you see that might be worth noting?
The veins.
Yeah, so there are veins. There's some veins here that are roughly parallel to the layering, and some cross-cutting veins. So there's that one that cuts across like at an angle. There are also ones like here that are more vertical. So there are a variety of veins. Yup. What else?
Some of the veins there seems to have been they seem to be offsetting just on the 2 different sides.
Like right here.
Yeah, and that one right behind you as well. It looks like there's.
So where is it offset?
You see that whitish layer by the
Here?
a little higher than one above. It's kind of yellowish.
Here?
Yeah, if you look at the top of that. And then
Like right here?
Yeah.
So it kind of bends?
Yeah, kind of like a vertical offset there.
Okay. Yeah. A little bit of a bend. It looks from here it looks continuous, but it does bend a bit. Yep. A little bit of a bend here. In terms of offset, that might indicate fault. That's a little tricky. I don't know. You can look carefully and see if you can see some offset zones. Maybe there are. That would be also something to check out. One thing that might be hard to see from your perspective, but right here, see that surface right there, and that stuff right there, that's a fracture. You can see it right up there. So there's a fracture right here. It's probably hard to see from your perspective because it's roughly parallel to the face here. There's a fracture coming in like that. This surface right here is also a fracture surface. What else?
There might be a change in dip in the banding from there to
Okay. Yeah. one of the things that also you check out is, I mean, right in here, you can see these bands are pretty continuous. You can follow them across. But then trying to take those bands, and you can see there's a contact between some gray and some kind of tannish color stuff, and it's pretty well defined. But then what happens when you come up here? It's not as clear. So you can try to work that out. Looking at the photograph may help with that, but frankly, the photograph, really the best way to do this is to convince yourself in the field about where the contacts are, and then look for it in the photograph. Okay, what else would be something you'd want to indicate in terms of detail?
About the hole in the bottom. There's just some, I don't know, I think it's maybe smeared with dirt or something.
Yeah. So one of the things that happens is, see over here, this is all just got water that runs down and smears clay or smears fine grained stuff on the surface, and that same thing has happened here. And we've scraped off to where you can see that it's white, but we didn't scrape all of it back in there where it's blackish. So that's just surface cover. We could go in and scrape there, but I don't know. I think probably let's just not do that. That would require a little more work in there to work under this overhang. Anything else that maybe is not like strictly geologic? It might be worth noting.
The water line.
Okay, yeah, sure, the water line. Yeah.
I think it's kind of similar to that, like this part of the river this is just a constant cut bank.
Yeah. Yeah. Actually, I mean, what might be good too is, you know when we did the map up of the gardens, we did paste and compass and with some sketching. So here, what you might do is just do a little sketch map of this right in here, this area here, where you've got this bend, and where the outcrop is relative to this bend. Yeah, that's a good point. We haven't really been doing that, but I like that. Okay, so there's one more point that I want to make in terms of stuff that
So this is a fairly tight bend here, and then the river continues that way. So we're kind of like on the outside bend of the
The
river.
roots are impressive. We got a
And
bunch
then
of
we'll
roots
go
up
up the
here,
roots.
but then, and it looks like most of the roots, the real density, well, up at the very top, we've got roots, horizontal roots that are crisscrossing. And then in this area, we've got all these vertical roots, and most of them stop right around here. But not all of them. There's some of them that are dangling down, just hanging in the air, that are deeper. But there's also others that are actually embedded in the rock here, that have penetrated much deeper than this. So there's some here, and where are these roots? These roots that are penetrating down deeper. They're in the fractures.
Okay.
They're in the fractures in the veins. So there's one. Yeah, they tend to follow these veins down. So, you know what the roots are after? Water. What else? Nutrients, yeah. So, one of the main nutrients that they want is iron. So, roots will have exudates, they'll have chemicals that they give off that will break down the iron-bearing minerals and allow them to extract the iron. So we have this area here where pretty clearly iron has been mobilized, and we've got roots coming down here. So we really don't know what the connection is, but certainly seems like the roots that are penetrating down along these fractures may be contributing to the oxidation of the iron. At this point, we could maybe note that as a concept, but what we could do for sure is just document where the roots are relative to this zone of oxidation. Yeah, I mean, I guess in terms of the roots and the oxidation, it's a little bit hard. It's a chicken and an egg kind of thing. Are the roots there and causing the oxidation, or are maybe it's just coincidence that it's oxidizing the place that's more permeable and the roots are following that? So that's a little bit.
Should we, if the roots are going to be an important part of it, should we ID or attempt to ID the plants that they're coming from?
I don't know how to do that. That would be tricky. I mean, if you could, if you had some time, you might document like the size of the roots and things that you could describe easily. That would be relevant.
I guess you could do like a leaf press, and then you can clean the leaf.
Yeah.
If you want to do that.
I mean, you could do a leaf press of these, but yeah, sure, I guess so. Yeah. Or actually, I've been trying this out where I take a picture and use lens.
Or I like seek.
What is it?
Seek.
Yeah,
So similar thing.
I don't know that one.
Tell you hold it up to the leaf and it'll try and tell you what genus it's in.
Oh,
pretty-
so it's a kind of overall idea.
Yeah. It's pretty amazing. So yeah, you could do something like that. Okay, so one more thing. We've got this feature here, this unconformity. What do you think about how that thing might form? Unconformity. So for sure, we're going to have to, for sure this material extended up here at one point and it was eroded. So we had some kind of mechanical erosion. I mean, we've got chemical weathering all through here. But we have to have some kind of mechanical weathering or erosion to take the material, the saprolite that was here and remove it, cut it away. Yep. So what kind of erosion mechanisms do we think might be at work here? So the stream, so we could have, I mean, I guess it would need to be like when if the stream was up here, and so when streams erode, they do it when the water's high, like a flood, high energy flood event would cut material out, and then typically what's happening is that flood that cuts down the deepest, the big flood, as the water level starts to drop, it deposits the material it's carrying, and usually it's going to deposit the coarser material first. So you get, on top of unconformity, you get coarse gravel, the gravel lag that you often get on unconformity, and then it binds up. So that's typically what you get for an unconformity that's cut out by stream erosion by flood. So what do you think? We got a finding upward sequence there? Nah. I mean, right from here I can see there's some clasts there. Maybe are a little bit more class than up here, but it's hard to say. So, I don't know. I mean, maybe you could have stream erosion, but it doesn't look like what we'd expect for stream erosion. So what might be another way to do it if we're not doing it with a stream? What? The roots. So how would the roots do it? Yeah, so I mean, one of the things roots do is they go in and they expand, and they're really good at expanding. You see sidewalks buckle, so roots can definitely break stuff up and disrupt it. And yeah, for a while I thought that was what was going on, but just, you know, if that's what's going on, we got roots down here, we got more roots up there, but it seems like if it's just roots going in and expanding, it would be kind of gradational. If this stuff would be kind of broken up a little bit, and then a little bit more, a little bit more. It seems like it would be gradational. So that's probably going on, but I don't see that as giving like a sharp boundary.
Like landslide.
So you could have a landslide, yeah? Landslide would give you a sharp cut like that, for sure. And if we were on a slope, I would say, yeah, maybe so. But we're kind of at the bottom, and it could be. It could be. Well, that's kind of the alluvial thing where you would erode, and we would expect this finding upward. So, could be landslide, but what else happens with roots? You know, what happens with roots when the tree is done?
Pull everything up with it.
With what?
Pull everything up with it.
It pull everything up. I mean, this thing fell in. If you go up here, and you go up in the forest, you know, a certain percentage of those trees have fallen over, and the root ball, it takes the roots and just picks them up. And when it picks it up, it fractures between the root ball and the underlying material. So the process of the tree falling over and the roots pulling up could be a way to create a sharp surface like that. So I don't know what happened here, but that would certainly be a mechanism that could give you this. Along with, I mean, landsliding is also a possibility, and floods, maybe, you know, maybe. I mean, maybe also, yeah, I don't know, maybe we had, I mean, certainly the floods, that kind of erosion would be a contributor, but it seems like if we had that material is gone. And so, you know, maybe the trees, it's kind of, the trees falling over would be a form of like bioturbation, right? Okay, so what we want you to do now is, well, let's take a look. You have the photographs?
It's the front page of the
photographs out and take a
aquifers
look at
handout.
them, and just briefly discuss that part of it. So this photograph we made, I think it was made last year. So the outcrop is a little bit different now, but it's still quite similar. And the photograph has got some nice detail in it.
And if you're watching the recording, here's just one more shot of the face, and then you can pause it so that you can do some macro scale descriptions, and then we'll zoom in on parts of it later when we go to describe it up close.
Okay. So, see the photograph. What I would do with this is go and look for features on the outcrop, and then find the features on the map, and draw in the features on the map. What I did when I was working on this originally was to draw in contacts that I could find on the field and then follow for a ways. And so you can see these contacts here. And then also I have numbers written in here. So each one of these units, or each one of these locations here, is a unit that I felt I could define and follow ways laterally. And so these numbers are keys to descriptions in my notes. And so then when this is done, I can go and trace this out using some kind of software. I just used Excel, or I used PowerPoint, and then color it, with some software. And so I have the layering here that goes up and follows as far as I can, and then I've got this the contact. This sketch doesn't really have the contact with the oxide layers too much because I was focusing on the individual bedding or individual gneissic layers. Here's the nonconformity. So I guess the key is that find it here in the field first and then indicate it on the map. Now, what we found yesterday was that it was kind of hard to write on these photos. Does everybody have, well, I brought some pens, I brought some Sharpies that should allow you to write on these photos. It's a permanent marker, so you gotta, make the mark and be comfortable that you're gonna live with that. I don't think actually can pen or pencil even write on this stuff. Yeah. So anyway, I've got the Sharpies. You're welcome to use the Sharpies. Just maybe return them because we only have a few of them. All right. So what we're going to do now is get going with the exercises, and I think the best approach is to split up into the two groups. Have one group go and get started on the mapping, and the other group can stay down here, work on the two aspects of the exercise, the sketch, and maybe a sketch base map, and then the more detailed map that you'll turn into more of a finished map. And so I guess for this exercise down here, what we want you to produce for the assignment is really two maps: the sketch map from your book, and then a better quality, more detailed map from the photograph. And let's also have just a sketch map of this little area, this little bend in the river. Okay, so very good. I don't know. Anybody really itching to go do some mapping?
So what all needs to be indicated on the photo?
Well,
Units, of course.
yeah. So what I was annotating was what I was trying to do was identify units here. Identify units here that I could follow as a map unit. And so from here to here, that was definitely one, and I could follow it along, and then I tried to follow it along here. It looks like it's right here, so right here, and follow it along here. So basically, it would be mappable units at this scale. That's what I was going for. And then there are mappable units in the weathered out gneiss, and then there are also these fractures, the veins. And when you're looking at the veins, one of the things that you'll want to check out is try to get the mineralogy. And one of the things about the mineralogy is that this is weathered material, but what you want to describe first is the minerals that are here now, as best you can, or at least describe what it is, what their characteristics are. For example, you might be able to determine that this has got some clay minerals in it, but it could be hard to identify what the clay is. But then then you can also, after that, estimate what you think the parent materials were. I mean, for example, we've got some white clays here, and I don't know, this is white clay that is kind of poorly cohesive. Anybody remember back from mineralogy, what that might be? Yeah, so we have kaolinite, so that would be what's here, and then kaolinite is often derived from, so we could describe that as like what we would assume, what we might infer the parent material was. Okay, and potassium feldspars occurring in veins like this would be kind of a common occurrence. But it's also then, an inference or an assumption. It's not really what we see here now. So we would want to include both of those and make sure the description is distinct from the interpretation. You've seen some interesting donation of these veins. You can see this kind of a selvage here on the side. So we got a donation here of this one and somewhat different donation on this one. So that would be an aspect we could talk about. There's some interesting mineralogy here. There's these little specks, little brown specks. So what do you think might be a brown speck in a metamorphic rock?
Ready brown.
Hematite?
Hematite? Well, originally,
They look like that.
hematite-ish now.
Oh, garnet?
Garnet?
Yeah,
Okay.
probably so. So those be some weathered garnet. Another thing too, so this has the look of bitype gneiss. Another rock type that we have around here is amphibolite. And this rock over here is so up there is some amphibolite that, I don't know, might have more or less been in place. And you see that this is a little bit different color here. So there was more blocks of amphibolite in place here in the past. It's kind of eroded out and it's down here now. So you might check this out if you brought a hammer down and break off a piece. Stuff. Anybody do any asking? Might be fascinating. Anyway, we might also break this open. So this is amphibolite's got what kind of minerals? Amphibolite. Yeah, and so hornblende, and how do you identify a hornblende? Black. And what's the? Yeah, so from the cleavage. Yeah. So maybe check this out. If you got a hand lens, see if you can find the hornblende cleavage. Yeah, maybe you can. Some of it's pretty weathered out places. That, I don't know. This stuff all looks really quite weathered. We might look around and see if we can find some stuff that's a little bit fresher. So we'll check that out too. All right, so we'll have a group get started here, and how do you want to take them up? And
Yeah, we've got S. Are there S and T today, please? Do you have a preference?
I don't.
Anyone in the groups have a preference, or rock, paper,
Yeah.
scissors?
How about
Let's just finish.
How about S?
Okay, let's finish the.
How about S get started with the
We're gonna-
mapping?
We're gonna start.
Start here. Okay.
Dipped it.
Are you S or T?
So S is mapping, T is here.
Okay.
Okay, and recording. I'm going to give you close-ups of some of these places, and then I'm going to cut the recording. You have, as Dr. Murdoch was saying, in your aquifers packet, you have a picture of this. So your goal is to map on some of these zones that we talked about onto that picture. You also want to do a sketch. So using some of these frames that I've given you where I'm standing quite far back here and you can see this whole wall, you can pause the video and do a sketch, macro sketch, just like students in the field here are doing. And, yeah, no worries. And then for your map, you're going to also want to have descriptions. So for example, if we go in to one of these veins that are cutting through, we want to look at what's in here and try and describe the composition. So I'll help you out with some of these. This one, so I've zoomed up into this bottom zone where we can see these gray bands in the ice a lot more clearly. So you've got some information in your background prep about what composition this might be. It is saprolytic, so it's pretty hard to identify minerals since they are so weathered. But you can maybe see in the video there's some kind of darker specks. These kind of have a reddy brown color to them. So the hypothesis would be that these are weathered garnets. And then the other feature in the gneiss is that when you go up further into this top zone, it's a lot more reddy brown. So this could be due to oxidation of iron, due to the processes from the tree roots that Dr. Murdoch was talking about. But we really can't, if we're identifying limonite versus hematite versus goethite, we can't really ID that in the field, so we can just say that there's describe the color of the iron oxides. The last kind of major thing to see when we're close up here are these veins. So some of them have these really distinct zones on either side of them. And again, we don't want to do too much interpretation of what those are, but you can talk about how you've got these clear edges on either side of the vein and what you think those might be. In terms of minerals in here, there are some coarser crystals that haven't broken down. I don't know if you'll be able to see this, because I'll be able to focus on it. But they're kind of clear in color. They haven't weathered into a different, or changed into a different mineral like some of the whiter stuff has. So these to me look like this might be quartz. It's pretty, again, robust, doesn't break down very easily. But then in these veins, you've also got a lot of whiter stuff that feels very, very fine-grained. It kind of sticks together. It's a little bit cohesive. So this is what we were identifying as kaolinite earlier. And then you can see in the veins, again, it's all very fine-grained, but if I pull out a piece of this, you probably can't see this in the camera, there look like there's little flecks of a dark mica in this as well. Kind of actually like a medium-colored mica, maybe in the phlogopite range. Again, I'm not sure if you can see, but if you see some kind of shining in those veins, like here, that's the mica that's reflecting the light back to you. There was also, within these veins, there was a couple of them, if I can find them again, that were much more quartz rich. I think. No, that's that one. And some of these, let's see. And some of these I'm able to kind of take out some pretty large chunks of minerals. So there's some big pieces of mica, and those are coming out of the back up here. This vein that's kind of under the overhang of part of this, so branching out onto that main kind of X in the middle there. So in terms of mineral descriptions, that's kind of all you can do because it is so saprolytic. If there's anything you want more detail on after watching this recording, I would encourage you to shoot your group members a text or reach out to me, Dr. Scribner, if you have more questions. But I hope I've given you enough footage here that you can get, your rough sketch done, and then your map with these different zones and different descriptions. So I'm going to cut the video, and then I'll start recording again when we're going up to do mapping up in the parking lot in the well field. Alright, so now what we're recording for you is the mapping of the garden's well field. So the first thing you want to do is get out a piece of grass paper and put your north arrow. In our case, we're facing the parking lot here. And you've got, there should be like Google Map screen captures on Canvas for you to give you more of a sense of orientation. And
just 10 feet. It's like 40 here and like
north is, well, it's kind of off in this way. So we'll show you a map about how to get that set up. And Wade is going to explain selecting your base station and how you want to orient your map.
So the first thing you want to do is select the base station. So we chose this well, it's LAR2. And we chose it because it's the farthest, if you're facing north, it's the farthest to the right. And it just makes it easier to orient everything in relation to this on your page. So looking around, we have this corner, and LAR1, LAR5 down there doesn't go much farther to the right past this.
So this is kind of the edge of the area that we're in. And then the rest of the wells stretch out to it'll be to the left on your page.
And one of the things that I like to do first after selecting my base station is I can find a larger structure. So here we have the road. And once you measure your paces from LAR2, you'll have a distance that you can work with. And then you find the orientation of this road. And you'll have a very large structure which you can use to relate the other features such as wells inside your map.
So the first thing you're going to want to do after you get your north arrow on your map, and I would suggest you put your north arrow directly like pointing up, because you don't want to try to put your north arrow at an angle, is you've got to figure out what a reasonable scale for your map is. So if you were to measure this length along the parking lot here, what did we get for a length for that?
From LAR2 to...
No, so the edge of the parking lot, like what's the long dimension on their map have to be?
Well, so from LAR2 to LAR
sure, okay,
4
yeah.
down there.
So from the base station to LAR4.
Right, we have about 45 feet.
That's about 45 feet,
Yeah.
okay.
So because we want extra space to work with, we called it 50.
Okay.
And now, to give us even more space to work with, usually pages are about 11 inches, right?
Mm-hmm.
So we called it 10 inches. So in our map, we have 1 inch equals 5 feet.
Okay. And that's, remember too, when you're picking a scale, you always want to make something that's easy to calculate. You don't want to do like 0.75 of an inch equals 22 feet. So that's a nice scale where you're doing what did you say again? 1 inch equals 5 feet?
I think it should be
10 feet. 1 inch equals 10 feet.
I was wrong, yeah.
That makes more sense. So now what I think I'm going to do is I'm going to kind of tag you onto one of these team members. And as they're making each of their calculations, I'll give them to you so that you can be kind of building your map as you're watching through the recording. So Mike, do you mind if I become your extra limb? So what did I miss in terms of what you've got on your map here?
Well, I just put down, LAR2, which is this well here as our base.
Perfect.
And then I have my north arrow, and then I got my scale. And I'm
have
about
you paced that already? So
Yeah.
LAR2 to the parking lot edge?
Yeah, so I paced this a few times, and I'm
Okay.
getting 6 paces.
6 paces, which for you is...
So I forgot my exact conversion, so I'm just
Okay,
going to
so you're
multiply
gonna
by
calculate.
2.5 and then keep it, 18. So that's actually a little higher than what my teammates got, but yeah, they were pacing around 13, 15, so I might include it to that because I think that's more accurate.
So you're going to do 15 feet.
I'm going to do
Okay.
15 feet to the road, and then, yeah,
Okay.
just struggling without the table here.
So again, the first thing you're doing is you've put LAR2 on your map as your base station, and you're drawing in a line that will be this way on your map for the edge of the parking lot. And the edge of the parking lot obviously isn't perfectly straight, but we're going to say that it's perfectly straight in the map.
You might take a step. Thank you.
And we're saying that LAR2, and they've done this using different group members pacing it, and they've also had group members pace multiple times and taken an average. They're saying that LAR2 is 15 feet away from the edge of the parking lot. And again, this isn't perfectly north, but your north arrow is going to be pointing straight, and then we're going to give you azimuths of, for example, the edge of the parking lot.
We actually have that one already.
Oh, do you have
What
that one already?
azimuth did you get for the?
I just don't remember what exactly. I've got notes here. Let's see. Parking
I
lot.
haven't done that.
260
part,
degrees.
I had it from
So the
before.
azimuth for the parking lot, so this line that Ethan is standing on right now, is 260 degrees. And again, the distance from the base station to the edge of the parking lot, if you're going straight out towards it, is 15 feet.
Oh, it's the third one on the left. There you go. Yeah, yeah. So when you come to New Jersey, you can be like, oh, actually, that's the third one on the left. Stanton. You want to know my town? Stanton. There's a church. There's a general store.
So Jack is currently pacing LAR2, which is our base station, out to our farthest well, which is LAR4, right?
Yeah.
LAR4.
So about what orientation do you get for the?
And he's going to do this multiple times, and then we'll take an average of it. And as you're working in a group too, it's important to remember that you can utilize your group members. So they are probably not going to have every single person measure every single distance and every single azimuth. They're going to utilize team members to do that so that they don't all have to repeat it. Hello, Christy. I'm eating, so I have dog friends.
Yeah, that. And we have LAR2 to LAR5. 5 is this guy.
You got
So did you get a distance from LAR2 to LAR4?
Yeah, I got 42 feet.
Okay, 42 feet. And did you get an azimuth?
I got 263 degrees.
263 degrees.
if that-
So LAR2 to LAR4 is 52 feet, I've already
42 feet,
42 feet, and 263
263 degrees.
degrees azimuth. Never mind, a minute and 60, I'm switching. I'm just repeating every measurement they get. I'm just repeating that and kind of showing them where that is.
That will be over there. Here. That, 263.
Jetpack joyride.
which one are you measuring now?
I'm just seeing if this is about correct.
Checking the pace.
Seeing if the direction is good. I think it is. Just have to get out the compass.
LAR2. You got LAR4. LAR3 should be right there. LAR1, and LAR5. LAS1.
You guys do the ad.
That one is into the saprolite, so it's not as deep.
I got it to be around 260, but I think I'm gonna go down to the well and then just do distance, and then just connect the 2 points.
Do the one past. Wait, what's the one right past LAR one here?
I do.
This one in the green,
Yeah.
that's LAR3.
That's 3? Okay. Do that.
Yeah.
Yeah. And then the parking lot, since it's too big, that could close. Yeah. Okay. So I didn't, if we do 2 to 4, then 2 to 5, and 4 to 5 is different.
I wouldn't do that.
Okay.
I'm not about this. I'm already going up
Yeah.
slow. So because these are all nice and warm, I would be doing everything real quick.
Okay.
20 minutes. You don't need 20 minutes to put the battery.
Yeah, 20 minutes. Well, I've got another one in my companion pack. And there's more in the charger. That's an empty 120 liters charger.
I'm gonna get the estimate in case for all the wells, and then just do all
So
of
now
that.
Jack is pacing from LAR2 to LAR3, and he's doing it 3 times, and then he'll get a 3.
How many paces did we get just about?
It's like 10.5. So multiply that by 2.62. I got 27 feet.
27 feet.
An azimuth of 248.
27 feet from LAR2 to LAR3.
2 to 3.
What was the azimuth again?
248.
248.
That's 27. 27.6 feet.
Can do the other ones.
I did 4, 3, and 1.
I'm going to LAS1 right now.
So we can go 2 to whichever one that one is.
That's 5.
Yeah.
Here's
Which
a
I actually,
view
we have
of
the
these
data for
again
5
if you
from the
didn't get
last
some of
thing we
these.
ran.
Oh, yeah.
So
LAS1
so
we
2
got
to
the-
5.
What's
we
this
got
guy
the
here?
estimate of 250.
That's a good question.
Are we doing him? Because there's no...
And then
no-
this one, we've got LAF1 in this notebook for you.
Wait.
Oh, LAS1 hasn't been written. Oh yeah, here it is. LAS1 is an azimuth of 250.
I can already do that one.
if you wanted to base, because I think you're more accurate with that, I can choose that.
So LAS1 was an azimuth of 250, and then the distance was 15.5 feet. And now Ethan looks like he is doing our base station again, LAR2, and he's now going to LAR1. And this is Ghost.
What was the distance to LAR3?
3 I got 27. It's kind of like it's just kind of in a line.
Yeah. Because I got
the
for
same.
LAS 1, 250.
Okay. Yeah, I did 248.
You want to get those? I think we're sharing them. It's LAS 1.
Group is a lot more ready to work together. I like it.
Oh, you already got LAS 1.
Yep. Yeah.
You have 5? You
I
have
did
5.
have 5.
Good. Here. 165 azimuth.
And so now they're just sharing numbers that I've already given to you.
You have.
I have LAR 453 and LAS 1.
Okay. You got those.
That's a 5 gallon
Great.
pail, I think, yeah. I think those are 5 gallons.
And then you guys have LAS LAS 1, 2,
And LAR 3.
and I have 3, but I don't have. I have 2 to 3. Oh yeah, 2 to 3 and 2 to LAS. For 2 to 3, I have 248 azimuth at 27.6. Now what's the other one you needed? That's the LAS now. 248 degrees again at 15. That's cool. That's the whole thing.
You have LAR 1.
209 degrees. And then 24 feet.
209. 24 feet.
So just to repeat that was a new measurement for you. So LAR2 to LAR1 was...
So we have obviously LAR
already forgotten it.
and then LAR 1.
240... One second, let me get it for you again. 200 and... Here we go. I'll zoom in on it for you. Better on paper. That was the last measurement we just added there. LAR2 to LAR1, 209 degrees, and 24 feet.
So there's 6 wells?
Yes. 1, 2, 3, 4.
Alright, I think I'm gonna put these guys.
And did you talk to them too about adding in the features that aren't wells? Okay.
Yeah. Okay, I'm going to do all the wells on my graph.
I told them they should add any outstanding features that you would need.
Help you orient yourself. Yeah. So I think people are starting to put together their maps now, and then what we're going to be doing is adding in some other features to help orient yourself other than just the map. So they'll do things like the edge of the parking lot. They'll probably do things like this. This is like a power outlet here. We're also going to want to get the drip line of the trees because that tells us approximately where their roots will be. So we'll kind of, it's hard to see from the camera here. This would be a good thing to look up on Google Maps actually. You could probably see this pretty well. But we're surrounded by trees around the well field. So we'll try and sketch in approximately what that looks like. I think for you all on the recording, I would definitely go onto Google Maps because it's going to be nearly impossible to tell from me just kind of panning my camera around here where the tree line or the drip line actually is.
I think it's about 8 to 9.
Do they have all their wells? The distances and azimuths for all the wells?
I think they just about. They might have That might not have gotten to
LAR
LAR 5
5,
yet.
okay, yeah.
You did?
You did?
Okay. Then yeah, they should.
Oh, I see. Where's that email pinging? Okay, I think in this case I'm going to cut the recording again. I'm going to change the battery as well, and then I'll turn it back on when we start mapping in other features.
49.97 feet instead of 50 feet. That's
Sorry,
what I
can you say that
measured at.
again?
283 degrees at 50 feet. And that's LAR2 to the power by the
Do you have the other one?
Yep. The close one here from LAR2 to power 62 at 13.
Yeah, 62 degrees and 13 feet. This electrical box. So now that we have the mapping of the wells done, what we want to do is find the drip line. So we're going to go from LAR2 here to a very close point, and then we're going to go over past LAR5 to a farther point in the vegetation, the drip line, and then we're going to pick a point over there past LAR4. We'll get those measurements and I'll start recording again. Alright, so we're going the far edge past LAR4 here. And you said that tree over there is where you're going?
Where's the thing that holds that together?
Alright.
The tubing.
So I did not undo it.
245 degrees, and I'll do
245, and now he's going to pace.
Which one of the slug tests would you like us to actually list on our analysis?
The stuff that we haven't drawn.
Okay. But that's kind of like a semi-permanent. Whatever.
Yes, ma'am. So, practice one. Yeah.
.13 and a half steps.
From that tree, actually.
Oh, to there. Okay. You're a every other counter.
Alright, so they got 35 feet from LAR2. That tree back there. 35 feet. Of this thing. Up to this tree. And that'll be the edge of this line particularly. Alright, we didn't get down from that area. What was the azimuth you got? 202. $15? 50. 15.75 feet. The azimuth from distance, that tree line back there, past LAR4. About 57 feet. Rich, what was the azimuth? 255 was the azimuth.
Alright, so we're back. We're just giving you some extra features here. So this is what Jack's finished map looks like. But we just want to add in these. I'll zoom in. Sorry. So we've got LAR2 always using that as our base station. So the corner power. So there's for those. Then we've got it to the other power, which is the one in the left side of the map here. And then we've got LAR2 to the, what does that say?
Sorry.
Corner lot.
Corner lot, yes.
Okay, so that's to that corner then, right?
Mm-hmm.
Okay, perfect. So those are the extra features all from LAR2. And then again, the tree line I think will be easiest for you all to do just looking at Google. Jack's is very detailed. You don't necessarily need to have it quite that complete. And then he's also got, do you have this azimuth for the edge of the parking lot?
I think 260. 80 or 260? 260
80 or
around.
260, okay, for the length of the parking lot there. And do you know the length of it?
Oh, we just went north and found the distance
Oh,
from
okay,
here.
perfect. So they just
I
went
think
from
the
LAR2
distance-
up, and then you have the corner here to LAR2.
Yep.
Perfect. Thank you. All right, so this is a new video now. We are now mapping the parking lot. So the first thing that they're doing is that they're piecing the edge of this parking lot, or this edge of the parking lot, and then they're also going to pace. You can see it's much longer in this direction. So they're pacing both of those to get an approximate length and width, so then we can decide again what the scale we want to fit on a page is.
Well, we want to make sure that more than one person is doing each one of it, but as long as there's at least two, we should be okay.
And so do you want to tell them what the goals for this one are, what they're going to want on their map?
Yes. So once we have all of the parking lot details down, what we're going to do is we're going to paste from these flags. We're going to get the azimuth and the pace between the flags.
There's one, you probably can't see it yet, but way down. Oh, there it is.
And we're going to follow the flags all the way around the parking lot. And once we're done, because it's not a straight linear feature everywhere around, you're going to have an error somewhere in your pacing, and we're going to try to find or calculate that error as we go around.
So we're doing this map differently. The previous one, we had a base station. We still have a base station, but the previous one we shot out all the points from the base station, versus this one we're doing it as a traverse. So we're starting and ending, in theory, at this flag by weight. So you're going to be measuring closure error at the end, which will be, we know we were supposed to start and end at the same flag, but our end point is highly unlikely to actually be at our start point. So then we're going to calculate the distance between those two as our closure error. So again, what we're starting with is just getting rough dimensions of the parking lot so that we know what our scale will be. We have a new dog who's joined us here. She's being quite the little monster, trying to dig up something from the parking lot. What'd you get, a leaf? Oh, that's exciting. So I'm going to, again, just so I can make your video a little shorter too, I'm going to cut this and then I'll come back in when they've got the dimensions of the parking lot figured out and then we've got a scale. And when you're setting up your map, of course, you always want to have a north arrow. So you're going to, north again is kind of like just off from dead center here. So, but you're going to orient it on your page so that it's pointing straight up and our parking lot will be angled out from that. All right, so now what we're doing is we're trying to figure out a scale. So these guys here have measured that from where we are at this edge of the parking lot all the way down here to the end of the parking spaces is 342 feet. And they know that this edge of the parking lot, which is our well fields right back there, there's our trailers, was an azimuth of, we'll have this on the last video, I want to say it was 242. So now what we're trying to do is determine what is a reasonable scale if we can fit, we need to fit our entire parking lot on.
Let's see how far away the flag is. Because he's doing from here to the flag.
So Ethan's currently pacing out. He's coming back now. He's got the maximum distance. So he went to the farthest flag, which is at the very, very eastern edge of the parking lot. And he's coming back here, so he's going to tell us that distance. And that will be your maximum, I guess we'd call it an X dimension. Do we pack lunch today?
I did pack.
Good.
I chose not to. It's motivation to go all the way, and then we don't. So
I don't think we'll be here too much mass too.
I would say 2:30 maybe at the latest. We were a little longer yesterday because the rain slowed us down in the morning, but
That's to that part.
Yeah.
so the longest dimension is 376 feet. So I would probably bump that up to 400 for your paper. And then you're going to have to figure out what a scale. Sorry, I'm talking to the recording and to you at the same time. So if you've got 376 on your east-west direction, like I was saying to Ben, I would just do 400. 376 is, and the parking lot's going to be angled if you're north arrow straight up. So you want to make sure that you've got enough room. People yesterday, their like right corner of their parking lot was going off their page, and they were having to like tape an extra paper to get it. So you want to account for that.
Then we could have each inch before 8. Be kind of happy with that.
I think inch is 40 feet.
Yeah, each inch is 40 feet. But then at that point we should just do 50. Right?
Yeah, I'd just do 50, because then you're only leaving yourself an inch of wiggle room for that angled lot as well.
Yeah,
Like,
also.
depending on the angle, if that angle is too much, it might, go off the page like you said.
Yeah.
So I'm going to do 1 inch is 50 feet.
Yeah, 1 inch is 50 feet. I think that's a good scale.
I'm going to do 1 inch is 50 feet.
Yep.
So the next thing to do, this is what I was kind of discussing, it's kind of you can do it however you want. You either put the whole parking lot in and then do the flags, or the way I would do it, which would probably save time, is to kind of do it together. So like start at this edge, all you can see is a tree, but start at this edge of this corner of the parking lot. You've got your base station flag here, and kind of orient, so like figure out how many paces are between this western edge of the parking lot and the flag, and the southern edge of the parking lot and the flag, and then go, okay, now we're at flag 2, and also get the azimuth of the western edge of the parking lot at the same time. So kind of scoot yourself around the map like that instead of trying to do the entire parking lot and the entire flags. She doesn't actually eat them, she just like rips them to pieces. It's a fun activity. She's been at home sleeping all morning, so she's like, I got some energy.
Time to play. Alright.
She's a wood chipper.
Okay, so this western wall is 167. And since it's angled like this, the furthest to the left on the page will be the top.
And that's
Other way, I think.
just over 3 inches.
So did you get the azimuth of this western wall yet?
Yeah, it was 350.
Was 345. Yeah.
350.
Oh, I thought there's. Oh, yes, I'm remembering it wrong. Yes, yeah. So that needs to be your left. Mm-hmm.
The leftmost spot on the map.
Yes. Mm-hmm.
So that
But you can't put it too high because this northern edge is going to angle up. So really, the right corner has to be your highest spot on the map.
Okay. But it's going to be like within 50 feet.
Yeah, it was pretty dramatic because the north is a little bit angled this way, right?
Yeah.
So it was a higher angle than I thought it was going to be yesterday, and that's where they were running into issues with their parking lot going off the map, or going off the page.
Okay. So I think if I allow, if the wall is 167, I'll allow 75 feet, that point to go up 75 feet.
Sure.
So that'll be the most. Yeah.
Yeah, you got it stuck in your teeth. No, that's enough. So could one of you just read me off the dimensions, like the data you have, and then I'll cut the recording again so that I can get it all for them. Here it is. It's okay if they're not all written down. So we need the western edge of the parking lot. We had that length, right?
Yep.
So that is
345 degree azimuth, 167.
345 degree azimuth, 167 feet. And we know this edge of the parking lot as well, the southern edge, right?
Yep.
And what is that?
This one over here is 260 degree azimuth.
Okay.
Looking at 376 feet to the flag.
Oh, just here? Just to the flag?
No, sorry, from here all the way to the flag down there.
Oh, what did...
376.
Oh, I heard once. Okay.
Sorry.
So, no. So 376 feet from this southwestern corner of the parking lot all the way to the flag down there. And then did we have anything else
I
we were
have
working
up
with?
there from that flag to the kiosk.
Okay, so from the flag 2 to the flag which is at the kiosk here.
Was that one was
So flag 2 to 3.
72 degrees
72 degrees
and 229.
and 229
Basically,
feet.
that orange flag, yeah, I think right here.
All right, I'm going to cut the video again and then I'll come back in and give you some more data points once we have them. All right, so in the last segment of this video, what I'm going to do is give you all the azimuths and distances to the various flags and the walls of the parking lot, so you have that all. And again, it's going to be helpful if you utilize Google Maps. If you look up the Bob Campbell Geology Museum, we're in the parking, actually, so this is the Bob Campbell Geology Museum back there. So we're in the parking lot just to the south of it for reference. So we're in the southwestern corner of the parking lot right now. This flag here is our base station, so this is our starting point. And just for reference, the well field of the bottoms is at the southern edge of that parking lot. So the first wall of the parking lot that was shot in is this southern edge out past the white Jeep there. This one, we're calling it wall 1 of the parking lot, has an azimuth of 345 degrees and a length of, oh, nope, this is the wrong, let me see. This is the wrong wall, that doesn't make any sense. Okay, cut that. Let's start, let's reset. So this is our base station, which is in the southwestern corner of the parking lot. Let's start with this wall here. So this wall is a literal wall. It's on the western edge of the parking lot. And this wall has an azimuth of 345 degrees. So this is wall 1. I had myself misoriented. And this is 167 feet long. So then what we're going to do is we're going to start shooting in our points, and we're doing this as a traverse. So again, there's flag 1, which is our base station. And the first thing that we did was we shot from flag 1 to flag 2, which is out here. So the azimuth from flag 1 to flag 2 is 336 degrees, and these are 125 feet apart. So, sorry, I'm spinning around because I'm also got my dog on my leash beside me. On a leash beside me. So now I'm walking out to flag 2. So I'm walking along the western edge of the parking lot. And now from flag 2, flag 3 is close by. So now I'm just going to turn. Now I'm kind of lining up along my northern edge of my parking lot, and flag 3 is actually right here. So 2 things to give you from here. So now that I'm at the northern edge of my parking lot, I'm going to tell you that this edge is 298.8, can't read this person's writing, 298 feet in length and 72 at an azimuth of 72 degrees. If we're going from now flag 2, which is there, to flag 3, this is an azimuth of 74 degrees, oh my goodness. I'm sorry, it's been a long day. I'm not doing very well here. So flag 2, again, to flag 3 is an azimuth of 54 degrees, and there's a distance of 52.5 feet between them. So now I'm walking over, I'm continuing on my traverse to flag 3. Flag 3 is right here. And from flag 3, I don't know if you can see this or not, but there's this little kind of hut thing, and there's a flag right below it there. That's flag 4. So if I'm going from flag 3 to flag 4, that is at an azimuth of 74 degrees, and it's 170 feet to flag 4. And again, now I'm kind of walking along the northern edge of my parking lot, which I already gave you this, but I'll just say it again. The northern edge of my parking lot is 72 degrees as an azimuth and 298 feet long. So again, now I'm just going to walk along the northern edge of my parking lot here, going towards flag 4. And sorry, it's getting a little windy, so hopefully there's not too much feedback here. Yeah, this way. Okay, so I'm going towards flag 4, and this little signpost that flag 4 is by might actually be a good thing to put as like a little bit of detail in your map. So here's flag 4, and now I'm going to go from flag 4 to flag 5, which is, if you look, see that signpost right at the base, that's flag 5. So that is an azimuth of 112 degrees, and that is 172 feet away. And now I want to show you kind of what happens at the edge of the parking lot here. So the northern edge of your parking lot would continue past this little trail, and they basically shot it so that they assumed this was straight across, when in fact there's a road that goes up here, but so you could put a little break at the end. This is now the northeastern corner of your parking lot that we're standing in right here, but you see there's this gap where the road is, but they've included that in the length of the parking lot. Then as we're going along what would be wall 3 of our parking lot, we didn't get a length for this because it, one second here. Alright, we didn't get a length for wall 3 because it kind of curves around, so there isn't really a wall 3. But you can kind of, if you have all 3 other walls, you can fill that in. Alright, so now I'm walking towards flag 5. And now I'm at flag 5. And flag 6 is just over here across the mouth of this parking lot. So flag 6 gives you, flag 5 to flag 6 also kind of gives you part of the length across this parking lot, or across the mouth of it. Flag 5 to flag 6 is an azimuth 165 degrees, and there are 40.7 feet between the two. So last one, we're going to walk over to flag 6. Come on, girl. And now this puts us at the southeastern corner of the parking lot, kind of curves back. There's actually the southeastern corner of the parking lot there. And now we're shooting flag 6. We're shooting all the way back to flag 7, which is just again at the tip of that trail. You can kind of see it by Wade there. So the wall that we're kind of following, but not along the wall, is back to wall 1. Which was again 345 degrees, or sorry, this is wall 4, which is wall 4, the southern edge of the parking lot, is 260 degrees and 376 feet. And the way they measured that is that they went to the very last parking space here, and they started right at the tip of this parking lot. So the 376 feet is from this tip of the parking lot to the other tip, which is beside our well field. So finally, shooting in from flag 6, which is back over there, all the way back to the start, is an azimuth of 72 degrees and a length of 336 feet. So now we're going to go all the way back, flag 6, back to what we're calling flag 7, but is really meant to be, it should be, if we did this perfectly and we had no error, flag 7 would in fact be flag 1. We would be back at the exact beginning. So we'll get back here. Again, so now we're heading back to the southwestern corner of the parking lot. There's our trailer. There's our well field out this way. And we're coming back to our base station. And you're going to find when you plot your points that you're going to have some closure error. So in an ideal world, we would now get back to this flag and we would be at the exact place that we started. But because there's error in all these measurements you're making and pacing you're doing, there's going to be some difference between where we're ending and where we started. So when you map that all out, you're going to want to measure that distance between where you should have ended and where you did end. And that's your closure error, which is something you also need to calculate for this exercise. So that's basically the end of the parking lot map. Again, I know this is probably a little bit hard to visualize. I would use Google Maps to help you out. If anything was unclear, I know I stumbled over a couple of my measurements, and I was also trying to walk a dog at the same time, so the camera might have been a little shaky. Make sure you email me or your team members. Note that your team members did this yesterday, so they're going to have slightly different numbers, but they might still be able to help you kind of work out where these numbers came from.